I use the graph of f of x is equal to the square root of x to sketch the graph g of x is equal to negative square root 1/2 x minus 1 minus 2. State the domain and range of G. Is this a rigid and non-rigid transformation? Let's go ahead and try that now. We've already seen the graph of f of x a couple times, square root of x, pardon me, a couple times today, so I'm going to graph this pretty fast. 1, 1, oops, 0, 0, 1, 1, and 4, 2. Okay, so there's f of x. Now with g of x, we have to look at this function very carefully. In fact, it looks a little weird. Now, it probably looks a little weird to you for different reasons than it looks to me, but I don't particularly like this part because what's happening there is a very hidden horizontal shift, okay? So we're going to clean this up a little bit before we go ahead and graph it. I'm not really going to change much, but instead of looking at it as a 1/2 x minus 1, I'm going to take out a half from both of those. So if I take out a half, I have an x, right? No big deal there. But if I take a half out of a negative 1, that's the same thing as minusing 2. And so what this function isn't doing is it's not showing us the right horizontal shift. So watch out for that. This horizontal shift is actually 2, okay? Not 1. It's going to be 2 to the right, not 1 to the right. All right, now that we've cleaned it up a little bit, let's go ahead and identify which transformations we have. Here we have a flip over the x-axis. Here we have a stretch of 2, right? Because inside the function, it's opposite, right? For the x's, everything is opposite. Minus 2 is going to be right 2. But then outside for the y's is just going to be normal down 2. Okay. Let's do this color-wise. So let's make this one green. Flipping everything on the x-axis, we're just going to go from left to right. Just going to go from left to right. So 1, 2, 3, 4, 5. 0, 0 will stay the same. 1 now goes down to negative 1. 2 now goes down to negative 2. There's g of x. I don't think I'm going to draw the line because that's a lot of lines. Next up, we've got stretch of 2. We'll put in orange. So each one of these, I'm going to take the x values and I'm going to multiply it by 2. Remember, it's opposite. So I'm doing a divide by 1/2. In other words, I'm multiplying by 2. So 0, 0, again, going to stay the same. 1, negative 1 is going to become negative 2. Negative 4 is going to become, or positive 4, pardon me, it's going to become 1, 2, 3. It's going to become 8. So we see it's all been stretched out, right? Okay, cool. Next up, we'll do this one in blue. Right 2. All those points are now going to go right 2. So 0, 0 finally gets to move. Right 2, right 2. And there's that. And then everything finally is going to move. We'll put it in brown, down 2. So this is brown, brown, down 2 from the blue guys. And here we finally have g of x. The domain of g of x, right there. 2 to infinity, the range of g of x, including negative 2 to infinity. Is this a rigid or non-rigid transformation? It is absolutely non-rigid. Half of these are rigid, but we have 3 of these are rigid, but we have 1 that is non-rigid. The orange one is non-rigid. It stretched it out so that 1 became 2, right? And then that basically kills it for everything else. This is a non-rigid transformation. Fabulous. All right, so this isn't the only way. These two problems aren't the only way you can get a transformation. What if you don't have an equation to start with? If you don't have an equation to start with, then you just reorder your ideas a little bit, okay? For example, below, example 7 here, below is the complete graph of y equals f of x. We've seen this graph before when we were doing intervals, things like that. Oh, that's to come. That might be to come. Sorry about that. We will see this graph again, and we can use it to graph g of x. G of x is equal to 4 minus 3 times f over 1 minus 2x over 2. A lot of transformations have been applied. But notice it's got an f of x in there, right? It didn't give us the parent function. It just gave us the parent function as f of x. And so if we adapt our ideas a little bit, we can use these guys to help us kind of find the new points, all right? Let's clean this up just so we can kind of see what's going on here. We do want it to take the format of kind of a sine looking function or a cosine looking function. You want your stretches out in front. You want things surrounding x in between. You want x first. You want d on the end. And that's definitely not what we have here. So let's go ahead and clean this up. Let's do a split of the fraction. And then that reduces to 2, but let's put that one at the end. And let's also put the x term first here, and plus 2. Okay, now when you have the f of x notation, you don't have to worry about those about the horizontal stretch here because it's already taken care of for you. Okay, it's only when you're in an equation that you have to worry about that. All right. So what do I have here? I have A, B, C, and D. And according to this format right here, my A is -3/2, my B is -2, my C, careful, is a -1 because it's plus, right? And then D is a 2. So let's create ourselves a table here. Grab our original X and Y's, -4, -3, -2, 0, 0, 3, 2, 0, and 4, -3. Now we're just going to follow the list. Okay, we're going to follow the list on how to transform this. Add C to each of the coordinates. Okay, so it looks like we're going inside as we possibly can. We're going to add -1, because it's minus -1, to each of the x's. So x plus, well, I guess x minus 1. This is our C idea. So -5, -1, nope, -3, -1, 1, and 2. All right, let's see. That should have been a horizontal translation. Hey, look at that. Everything moved left. Cool. Everything moved left one. All right, next up we have B. We're going to multiply everything we just got by 1 over B, right? Because it's inside. We want to do the opposite. That's why we have an opposite C and an opposite 1 over B. Okay, so 1 over B, 1 over -2. To all of the things we just got in the C column. So that would be a positive 5/2, a positive 3/2, a positive 1/2, a negative 1/2, and a positive -1, pardon me. Okay, cool. Next up, we're going to multiply all the y coordinates by a. So this is going to be a times y. -3 times -3/2 is going to be positive 9/2. 0 times that's going to be 0. 3 is going to be -9/2, 0, and positive 9/2, because those are very similar. The last thing we're going to do is take each one of those we just got and add d to it. So the a column plus d. 2 is 4/2, right? So let's do 9 plus 4 is 13/2. That's going to be 2. Adding 2 to there would be -5/2, 2, and 13/2 again. And so our final x and y pair, we'll call them we'll call them, I don't know, x2 and y2. We get nope, just kidding. We get 5/2, comma, 13/2, 0, 2, 1/2, -5/2, -1/2, 2. Oh, not 0, 2, I apologize. 3/2, 2. Sorry, I'm trying to get this column and this column. And then -1 and 13/2. Okay, let's graph that bad boy. We could go into decimals. I guess it's all in halves. So this could also be 2.5, 6.5, 1.5, 2.5, -2.5, -1, 0.5, 2, and -1, 6.5. Okay, let's graph those. So 2.5, 6.5, 1.5, 2, 0.5, and what was it? -2.5, -0.5 and 2, and -1 and 6.5. Wow, that is so different than our original function, right? But let's look at these things. It was multiplied, so it was stretched twice. It was inverted by a negative. It was moved up to and to the right a couple spaces. All right. Looks good. Looks good. The last thing for this section, we're just going to create the create the equation from the function. Let f of x equals x squared and find and simplify the formula for g of x, whose graph is the result of f undergoing the sequence of transformations. So we've got f of x is equal to x squared. Let's just start there. Let's vertical shift that up 2. We'll call this, we'll just keep going. So x squared plus 2 would be the first transformation. A reflection about the x-axis would create a negative upon the outside. A horizontal shift right 1 would take this and go -1 plus 2. And then horizontal stretch by a factor of 2, we would have to use a 1/2 x minus 1 squared plus 2. If we simplify that a little bit, we get that g of x, and you can just write it over here, is equal to negative 1/2 x plus, or minus, pardon me, 1/2 squared plus 2. That is g of x. All right, so finding the equation, not as bad, right? The worst one, in my opinion, is probably this function within function notation. It's never been my favorite, but that's okay. All right, if you have any questions at all about transformations on functions, reach out to your teacher. Otherwise, I'll see you in the next video.